Lesson 6.5, Antiderivatives and Indefinite Integrals, Basic Rules and Notation. So we get to start learning some of our rules for integrating. And just a little bit about, we focus more here on the indefinite integrals. Okay, so a little bit of vocabulary definitions. A function f of x, capital F of x, is an antiderivative of a function f of x if capital F prime of x equals little f of x for all x in the domain of f. The process of finding antiderivative is antidifferentiation. So remember, taking derivatives is differentiation. Antidifferentiation is your antiderivatives. Okay, also the idea of integral. Okay. The family of all antiderivatives of a function f of x is the indefinite integral of f with respect to x and is denoted by, you got an integral sign, f of x dx. So when we talk about an indefinite integral, that's when we don't have boundaries. Okay, when those a and b values don't exist, those are indefinite integrals. So we won't have values to plug in to evaluate with. Okay, so that is our indefinite integral today. If f is any function such that capital F prime of x equals little f of x, then the integral of little f of x is equal to capital F of x plus c. Okay, and this is called the general solution. C represents a constant. Officially, it's called the constant of integration, but it's an arbitrary constant. Because the idea, if you think about it, when we're taking derivatives, what's happening to our powers? When you go back to first semester, you take derivatives of just powers. The powers are going down, decreasing, one less, however you want to say that, right? Okay. Antidifferentiation means my powers are going up. Okay. So with that in mind, with derivatives, we have terms that eventually disappear when we take the derivatives, don't we? Well, antidifferentiation is that plus c is that term that you might have to add in. Okay. So we'll have, if we don't have boundaries, we'll have to add on a plus c on our answers. Okay. So as we look at example 1, we know that if a function f has antiderivative f of x, then there is a family of functions which share the same antiderivatives, and they will differ only by a constant c. Okay. So state 3 functions here, f1, f2, and f3, whose derivatives are f of x equals 3x squared. So what can I take the derivative of and get 3x squared?
X cubed plus 5.
Okay. So I could say that f1 is x cubed plus 5. First of all, do the math. Do you agree with Doug? What's the derivative of x to the third? With the 3 out front, subtract 1 from the power, yes? So 3x squared. What's the derivative of 5? It's 0. Okay, it's gone. And I don't know if, I'm assuming Doug did this purposely. Does that match with one of our options over here? Yeah, that matches with this top one right here. So that's what I called f1. Okay, well, is that the only function that has that derivative? No, because that plus 5, the derivative of a constant 5 is 0. So what's another one? Okay, f of 2, I'm going to call x cubed plus 3. Is that one from the graph, I'm guessing? It is. So there's your f2. Is that derivative 3x squared? It is, because the derivative of a constant is 0. What's f3? X cubed. Okay, the idea that the derivative of x cubed is 3x squared. Okay, that'd be the most basic one, but the point is that's not the only one, is it? Okay. Give me another one. I know it only asked for 3, but why not?
I went for x cubed minus 2.75.
Okay. And I get it. It looks like that's a very close number, actually, because what it technically is e. X cubed minus e. Now, e is 2.72. Help me out, Doug. if you can figure out where to do it on this case.
2.72.
Okay, so,
I had to figure something out before you do that.
okay, so regardless, if we're, and that's the thing, does Sophie's work too? F of x equals x cubed minus 2.75?
Yeah.
Yes, it does. Okay, because does it have to be something that's even shown on this?
No.
Technically, it just says state three functions whose derivatives are 3x squared. So we could go on all day. What's the other one shown here?
X3 minus x cubed minus
Okay, so x cubed minus 5. Okay.
Just like
Okay, explain the meaning of plus c on your functions above. Okay, it's your translation, isn't it? Okay, that plus c is your translation up or down. Okay? So graph is translated. I'm going to say vertically C units. Graph is translated vertically C units. There we go. Okay. And so what we have here showing on this picture, guys, this is the family of antiderivatives, okay? We mentioned up here, somewhere up here, it talked about there being a family, right? There is a family of functions which share the same antiderivatives. So right here, this is your family. Okay, this is your family of all the antiderivatives of 3x squared. Okay? Well, not all of them, because there could be a lot more, but... Okay, ready for example 2? Example 2. Given each derivative, find the general antiderivative by guess and check.
I know there's one.
So, g prime of x equals 2x. If that's the case, then what is g of x?
X squared.
X squared. Because the derivative of x squared is 2x. Okay, now, officially, I need to put something on this answer to make it a little more official.
plus c.
Plus c. Okay? Because while g of x could be just x squared, and that means c would be 0, are there other values of c that could exist that could also work? Yes. So that plus c, unless you have numbers to plug in and evaluate and finish it off that way, which we'll talk more later on, you need that plus c. Okay? B. F prime of t is t squared. And I didn't really talk much about A because that one was obvious. You guys kind of just saw that and went with it. Thoughts on the antiderivative of t squared?
1/3 t cubed plus c.
What do you say about the 1/3 t cubed?
3.
Oh, the 3's cancel out, and then
Do we need the 1/3? Yeah,
Well-
because so what do we do to take if you and here's the thing, it's guess and check, right? So we put something down and we check it. You take the power 3, you multiply it out front. What's 3 times a third?
1.
That's 1, and that's what gets that 3 to cancel out. Subtract 1 from the power. 3 minus 1 is 2. And then the plus c that was added on. I just hadn't read it in yet. Okay. Okay. C. Y equals 1 over x, y prime equals 1 over x squared. We need to know why. Now, here's my thought. If you're going to do the derivative of this, I know we're doing the antiderivative, but same thought. If you're going to do the derivative, what would you have to do before you do the derivative?
X squared.
You would rewrite this as
X.
x to the negative 2. In order to think antiderivative, you need to do the same thing. Okay? So now, you've got to think. Now, the easy part is the power. if this is -2, are you thinking about what your power could be?
Negative.
-1.
It has to be -1, yes?
Oh my
Are you
God.
with me there? Because what are we doing? Instead of
we're
subtracting 1,
okay.
we have to add 1. -2 plus 1 is -1.
Yes.
Now, is that it?
No. You have to tag in a negative. Oh,
You're going to have to tag in a negative out front.
plus C.
And of course, before I forget, plus C. Now, try it out. If you take this power, -1, and multiply out front, -1 times negative is positive. What do we need? Positive. Subtract 1 from the power, and we're at -2. Now, you could also write this as negative of 1 over x plus c, correct? And I'm not saying you have to. You just have to be aware that they are equivalent, of course. Okay. And I don't know, all of these right here, we are working towards, it's guess and check, we're working towards discovering our power rule. Okay, which power rule when we take derivatives is what we've kind of talked about, where you multiply the power up front and subtract 1 from the power, right? That's your power rule when we take derivatives. We're trying to reverse that. Okay, how do we do a power rule when you do an antiderivative? Okay, now, D. df d theta equals cosine theta. First of all, df d theta. That's fancy speak for what?
F prime.
F prime of theta is equal to cosine theta. Now, there's not a rule here, so to speak. You just have to know what it is.
It's just makes me so happy.
Sine theta plus.
Oh, yeah.
Are we there? And that's half the battle, is getting the signs figured out, right? I heard discussion out there of, is it positive sign or negative sign? I'll be honest. I'm not one that with the sine and cosine just automatically know my antiderivatives rules. My brain personally goes to my derivative rules. And I say, okay, obviously there's a cosine, so I know it's sine. I work backwards. My brain says, oh, derivative of sine is cosine. If it was supposed to be negative, then I know I'd have to change it. Okay? So you just have to figure out a way that you can keep that one intact. Okay. Probably the challenge on the paper. F prime equals 2/3 x to the 3/4. So our job is to find F.
We're talking about the next one.
Okay. We'll start with the easy part. Or easier part. X to what power? 7/4, because we're going to have to add 1, yes? Because we're antiderivative. So when you add 1 to 3/4, it's 3/4 plus 4/4, which is 7/4. Is everyone at least there?
Yes.
That's the easy part to figure out, yes? Now, what to do on the next part?
What's the 2/3 equivalent of?
Like a decimal?
No, of in a fourth.
That is one way to think about it, yes. Okay. Well, she said 2/3 divided by 7/4. I'm actually going to think about it a different way. Dividing by 7/4
Multiplying by 4/7.
is multiplying by 4/7.
So
Now,
8/20.
think with me here. Look at this. The way I have it written out right now. This is not my written as my final answer, of course, but if we take the derivative, 7/4 is going to go out front. What's that 7/4 going to cancel out?
So
The 4/7 I have written here. And then what are you going to be left with?
2/3.
The 2/3 we need. And then subtract 1 from the power. 7/4 minus 1 is 3/4.
Plus C.
Okay, so when you get to the power rule, you will see, okay, and I'm getting ready to show that here in a moment. but you will see that they talk about whatever this power is, 7/4, dividing by that power. And so Natalie said divide by 7/4. Now, when it's a fraction, though, we want to think about multiplying by 4/7. If we go to the one right above it here, folks, the old power was 3. What did we have to divide by? 3. Okay? So if I clean this up, does this clean up at all? I guess it just multiplies, doesn't it? My brain is wanting to reduce it. 8 21st x to the 7/4 plus c.
Sure.
And again, here's the deal. It's not always going to be guess and check. We have rules. And once you, like derivatives, once we got into the process, it was a piece of cake, wasn't it? And that's what's going to happen on these basic ones.
Need more, you already know the last one.
Okay. Has everyone had a moment to think about f?
It's easy.
Okay. F prime is e to the x. So f is
E to the x plus c.
e to the x plus c. Because what's the derivative of e to the x?
E to the x.
E to the x. It doesn't change. So what's the antiderivative of e to the x?
E to the x.
E to the x with the plus c if you want to throw that in there. But, you know, same idea. Huh? Yeah. So what you'll notice is what? A, B, C, and E here can all fall into a power rule category. D, you just have to know. F, you just have to know. So you're going to have some antiderivatives, kind of like derivatives, where you just have to memorize. You just have to know. And then we're going to have some where power rule applies here. Okay? Okay. So, on this next page, the expression, sorry, I left this all as one page, so I may zoom in on the bottom here a moment, but the expression, the integral of f of x dx is read as the antiderivative of f with respect to x. So the differential dx serves to identify x as a variable of integration. The term indefinite integral is a synonym for antiderivative. So antiderivative, integral, along the same lines, just used in different situations, okay? Notation for antiderivatives. There's probably others, I feel like, but dy dx equals f of x, and dy equals f of x dx are both ones that you'll see. The operation of finding all solutions of this equation is called antidifferentiation or indefinite integration, denoted by sign. Okay, I don't usually hear that one. Indefinite integration denoted by sign. Yeah, I don't know about that one, but okay. So as we look at this, y equals the integral of f of x dx, which equals f of x plus c. Let's fill in a little bit of vocabulary here. What's the c? Constant. I'm going to officially say constant of integration. Okay. Okay. What's capital F of x represent?
Your function.
Okay, your function. In this case, it's the answer to an integral. It is your antiderivative. And I don't know why I started filling out this side first, but I did. I don't know that it matters. So it's your antiderivative. Okay. Dx.
Is what you're expecting.
Yeah, it's what you're expecting. So it is your variable of integration.
You'll respect your why.
And little f of x.
Integral.
Integrand is the official terminology, but yep.
Wow.
I don't think of the word integrand very often. I'll be honest, you don't hear me use it very often, but it is the official terminology if we want to go there. Okay? So, and this is one where think in mind here that when we talk about capital f of x. When you take the derivative of capital F of x, it's going to equal little f, because when you do the derivative of an integral, you're going to just get little f of x, right? Same thing we were kind of talking about in the last, was it in 6.4, 6.3, I don't know, somewhere, okay, in a previous lesson. Okay, now, I'm going to pause for a moment, and we're going to go to the next page. Actually, not the next page. Flip 2 pages. You have a page of basic integral rules. Or don't flip, just look up here, whatever the case, okay? But with this, okay, integration is the inverse of differentiation, differentiation is the inverse of integration. So we have on the left side some derivative rules. For instance, what's the derivative of a constant? Derivative of a constant is 0, cease to exist. So over here, what's the integral of 0? It's a constant, okay? So this is, you know, what's the derivative of kx, so a constant times x? Well, the derivative of that is constant. What's the integral then? If you have the integral of a constant, you're adding the x onto it, so it's kx. Notice all of these say plus c, right? The idea here, the derivative of a constant times a function. Well, keep in mind that constant can be pulled out front. Same thing can happen on integrals.
So
Okay.
is K and C the same thing?
They both represent constants in different places, but yes. You can have multiple different representation of constants.
Okay.
Yeah, but that's what K is here. K is a constant. Not to be confusing or anything, but it is that, you know. You can add and subtract pieces. You can split derivatives into adding and subtracting. Same thing can be done with integrals. Okay, power rule. I already talked about this. This is a big one today. Okay. In order to do the derivative, you move the power out front, subtract 1 from the power. Integral. In order to do the integral, well, instead of subtracting 1 from the power, we're going to add 1 to the power. And then you're going to divide by what that new power is. Like last time we divided by 7/4. We divided by 3. You're dividing by that new power is the shortcut. Okay? The rest of this page, the derivative of sine is cosine, so the integral reverses, yes? You just have to watch out for, like here, the derivative of cosine is negative sine. So if they're asking me the integral of sine, it's going to be negative cosine. There's some good ones to recognize here. Derivative of tangent is secant squared. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tangent. Derivative of cotangent is negative cosecant squared. Those will pop up. They're getting ready to pop up in our next examples. Okay? This is where knowing your derivatives is going to be important. Okay? And then you've got a few others. Derivative of e to the x, we already talked about that, didn't we? Derivative of a to the x, you don't see that one as often, but a being a number, a constant. Here we go again. But I mean, that's like saying the derivative of 2 to the x, where the x is in your exponent and the number is your base there. Okay? And so that one is a little opposite. Here's one that we get caught on sometimes. The derivative of natural log of x is 1 over x. You need to watch and catch what's the integral of 1 over x then? Natural log of x. Because we get in that habit of, oh, add 1 to the power. Well, my power is negative 1 here. When I add 1 to negative 1, I'm going to be at 0. And that's always kind of my clue that, oh, it's not going to be a power, it's going to be a natural log. Okay? So here's a reference page, right? Okay, let's go back.
Why is it absolute value though?
Can't be insides of a log can't be negative.
Oh, okay. So it's not anything special.
No. Okay, guys. Example 3. When integrating, think before you work. Practice will help you discover many tricks and techniques to make the integration rules fit your problems. Like anything, the more you practice these, the better they're going to flow for you, right? Okay. Derivatives at one point were we had to really stop and think, right, with our power rules. Not anymore. Integrals, it's going to be the same thing. Okay. Trick number 1, suggesting rewriting. The integral of 5e to the t plus 1 over cosine squared t dt.
Break it into 2.
It is, yeah, okay, so you can break it into 2 integrals. You don't necessarily have to. You can just think of it as 2 pieces here. Okay? That's not the rewriting I'm looking for, I guess. So, not integrating quite yet. Are you going to be able to integrate 5e to the t?
Yes.
That's going to be a basic one. Okay, if you're not there, we'll get it here in a moment. Okay? Now, whoops, I didn't mean to end my parenthesis there. Are we going to be able to integrate cosine squared t?
No.
We're not going to have something like that.
1 minus sine squared.
What?
1 minus sine squared. Or 1 plus.
Well, right now it's in the denominator, though.
Yeah.
My suggestion would be to get cosine squared out of the denominator.
Make it negative.
Just multiply by what cosine squared. Or cosine squared.
Well,
So one option would be to say cosine to the negative second, right? It's a positive 2. To get it out of the denominator, you can make it cosine to the negative 2. However, then you have to go, okay, what's the integral of cosine to the negative second? Do we know that? That's not one we know.
Oh.
Now, reciprocal trig functions here. What's the reciprocal of cosine? And that is secant. So cosine squared in the denominator is equivalent to secant squared in the numerator. Now, and it comes with practice, folks, okay? That's one of those things, it's rough right now. The more you work with this, the more you'll see it. Why is secant squared a good move?
Because then you get the derivative. Or whatever.
That's an integral that you're going to know. I'm not saying you know right now, but it's an integral you know. So ask yourself, what is secant squared the derivative of?
Tangent.
Tangent. Okay, so let's actually do some math here. What is the integral of 5e to the t?
5e.
Okay, so derivative of e to a power is still, or e to the x is still e to the x, constant in front of it. What's the integral of secant squared?
Tangent.
Not just,
It's just tangent.
just tangent.
Yeah.
Tangent t. Okay? Because, this is where my brain always says, okay, what's the derivative of tangent? Derivative of tangent is secant squared. My brain is constantly working backwards. And then, of course, you guys won't let me forget it, which is good, plus c.
What is that? No, just tangent.
You always have to have a variable.
That's not.
Okay.
I thought you put a squared on the tangent, but you don't. It's secant squared.
No, because the derivative of tangent is secant squared.
Yes.
Okay? That's the type of rewriting we're talking about. Okay, 1 over cosine squared, I can't do anything with that, but secant squared I can. Okay, number 2. The integral of 3x minus 1 squared. Could you integrate it as is? The answer is always yes. However, when you start integrating this and start talking about power, we're doing the derivative. There's a chain rule here. And it just gets kind of complicated then.
I don't feel like doing change.
Okay, so the recommendation here is that you rewrite this in a different form and basically multiply out 3x minus 1 quantity squared. So 3x minus 1 squared.
9x squared. 1. That's it. That's all I know.
9x squared is my first. What are my outsides and my insides?
Negative.
Negative 3x.
Negative 3x and
Negative.
negative 3x, which is negative 6x. What's my last?
Plus 1.
Plus 1. Are you guys, and here's the deal. If that foiling didn't work in your brain, you write it out longhand, yes?
That's right.
Okay, I mean, there is nothing wrong with, I need the visual. Do it if you need it, right? Okay. Now, let's integrate. And these are just three separate terms. I could write them as three separate integrals, but I don't have enough room. So we're just going to integrate each term. So integral of 9x squared. Okay, now I'm going to write it and our learning steps. Add 1 to the power, divide by that new power. So does it make sense if I say it's 9x cubed divided by 3? Does that agree with the 3x cubed you guys were just telling me?
Yes.
Yes, I'm just trying to, okay, that's your helper step. Integrate, integral, 6x.
Negative 3x squared.
Okay. Now, one option is add to the power, right? So if we add 1 to the power, we're at 2, and then divide by that new power. If you were telling me 3x squared, are you right? Yes, I just don't have it there yet. This is one you just have to know, the integral of 1.
X.
X, yes? If it's a constant, just tag an x on, so it's 1x, I guess. And then plus c. I'm going to clean this up, though, and say 3x cubed minus 3x squared plus x plus c. Take as many or as few of these beginner baby steps as you want. Okay? Okay, number 3. Looks like a really complicated problem. And what I will tell you guys, though, is that this problem, there's always something like this thrown into multiple choice or something. And when it comes time for AP review, you guys will get tripped up on it. Okay? Not really integratable, as is. You have a denominator that is 1 term. What can I do with that x to the 5th?
Multiply by.
Okay. So equivalent, not how I'm thinking of it, but I'm hearing make this x to the negative 5th, yes?
Mm-hmm.
Which, if you guys do that, then it's x to the negative 5th, and it's being multiplied by x squared plus 4x plus 5, yes? And then what are you going to have to do before you actually integrate? Now, my brain goes a different way. Nothing wrong with what your brains did, if your brain did that. My brain just divides each of these. I have one denominator. My brain just divides it. What's x squared divided by x to the 5th?
1 over x cubed.
I'm not going to integrate 1 over x cubed, though. I'm going to integrate x to the negative third. 4x divided by x to the 5th.
Plus 4x to the negative
4x to the negative 4th. Plus 5 divided by x to the 5th. 5x to the negative 5th. Now, here's the deal. If I distribute that x to the negative 5, do I get the same expression I just had, or I just got? Does it matter which way your brain goes? No. Okay? So, are you ready to try integrating? Okay, x to the negative third. What are you doing?
You're adding 1 to the power.
Adding 1 to the power, which is going to make it
X to the negative second.
x to the negative second, and
Divide by negative 2.
dividing by negative 2. I'm going to rewrite this here in a better form when I get done, okay? Plus 4x to the
Negative 30.
negative third, because I'm adding 1 to the power, and
Divide by negative 3.
divide by negative 3. Is this better than guess and check? You have a set way to do this now?
Mm-hmm.
Plus,
5x to the negative 4 over negative 4
okay, 5x to the negative 4th over negative 4.
plus
Plus c, yes. Although I'm going to clean mine up before, and I'll put the plus c on the end. Okay. X to the negative second. Now wait, how did I? Okay. You can do this a couple different ways. There's not a right or a wrong. I took mine back to positive exponents. Okay. Could you leave them negative exponents as well?
Yeah.
Yeah, it depends. It depends on what you're doing as to how you leave it. Okay, so here, if I x to negative second, if I take that to the denominator, this is
X.
negative 1 over 2x squared. Now this next one, it's 4 over negative 3, so I really should say minus 4 over 3x cubed. 5 divided by negative 4, so it's going to be minus 5 over 4x to the fourth plus c. Not the prettiest looking. And again, not that you couldn't leave negative exponents. Okay. Number 4, when you're ready, what are you seeing? Foil or distribute, whichever you want to call it. Okay. So let's start there. X minus 3 quantity squared is going to be x squared minus 6x plus 9 all over what?
Square root of e to the 1/2 x.
Square root of x, which is x to the 1/2. Now, nope, I kind of forgot my dx. Are we ready to integrate that?
No.
No, that's why this one says multiple options. We're using trick number 2, which is multiply or distribute. And now we kind of need to use trick number 3, where you need to write this so it's not in one big fraction. So I personally am going to divide each term by x to the 1/2. So x squared divided by x to the 1/2.
X to 3 halves.
Because 2 minus 1/2, 2 minus 1/2 is going to be x to the 3/2. Minus
6x to the 1/2.
6x to the 1/2, because 1 minus 1/2, plus 9x to the negative 1/2 dx. Okay. Integrate. This is where your rule comes in handy, isn't it? Because it's really bad looking, okay? I'm looking for a better word there, but I don't have it. Okay, so I'm going to write it out one way, and we can clean it up here in a moment. Although I'm running out of room, big time. Okay, so add 1 to the power, and we're going to have, where am I doing this? X to the 5/2, which means you're dividing by 5/2, which means if you want to go ahead and do it now, eventually you're going to, instead of dividing by 5/2, multiply by 2/5. Okay? I'll do that next time. Minus 6x to the, add 1 to the power, so 3/2, divided by 3/2, plus 9x to the 1/2 when you add 1, divide by 1/2. Okay. X to the 5/2 divided by 5/2. Two-fifths x to the 5/2. Okay? Because dividing by 5/2 is multiplying by 2/5. Minus, what is 6 divided by 3/2?
4.
4.
And here's what I would say. 6 divided by 3 halves is 6 times 2/3, yes? So that's 12 thirds, which is 4. I already have my minus right here.
Oh, okay.
So, sorry, I'm realizing you're getting hung up on my minus, but
Yeah.
my minus I already had in the problem. So what I say, minus 4x to the 3 halves. Start glitching. Plus, so it's 9 divided by a half, which is 9 times 2 over 1. So 18 x to the 1/2 plus c that I ran out of room for.
So
Okay.
so much.
Now, and I say, guys, I know it looks like a lot, but this one was easier than the one we did on the other page where we ended up with the 7/4 power, right?
Yeah.
Because you have that rule. Okay,
Ooh, can I just like
are we ready?
can I look the other way instead of doing
Well, okay, so here it is. It says, match each function with its antiderivative where c is a constant. This first set of 4 is pretty easy because what can you do?
Start from the right.
Can you start from the right and do that?
Yeah.
You can. Okay. Here's what if I start on the left, I'm going through and looking. Third box. What about that box right there? Which one do I know it has to pair up with?
Wanna just
No,
I don't know.
X to the 4.
All my others, their highest value is x squared. My highest power is x squared. This has a power of x cubed. So which one should it pair up with?
D.
The only one that has a x to the 4th. Can you do shortcuts like that and stuff when it's matching? Now, should you technically check all the terms?
No.
Not
You know, but, I can check 4x cubed, 6x squared, minus 2x. Okay, so we got D. Little pieces like that are nice. What else you know?
The first one is C.
the second one is A.
First one is C, he says.
Oh,
It's plus. That's not minus.
What are you going with? So, see, we're just using tricks here. We're not actually
I
doing
know,
the
that's
journey.
what I just did the first
But-
one, all of them.
But it's matching, so, and this is things to look for. So, okay. So Doug so technically D was gone. If you look, of the ones left, minus, 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 plus. So, okay, fair enough. Again, does it work?
Yeah.
6x squared, 6x, minus 5. That works. Okay. What else do we know?
The second one is A.
3x squared minus 12x plus 4. Yep. That means last one is B.
B. Just kidding, guys.
6x squared minus 8x minus 2. Okay. Okay. Okay, set B. 4x greater than 3 match the integral to its antiderivative. So, different form here, but it's still essentially the same question. And it just says x greater than 3 because of keeping our logs positive. Now, this is one where doing the derivative isn't a bad thing necessarily. It's helping us see it though.
First one is G. That's what I was gonna say.
Do you guys see it?
Yeah.
First one is G. Now, think with me. If I take the derivative and check this, the derivative of natural log of something is what? 1 over something times the derivative of something. The derivative of 2x is 2. That makes sense then, doesn't it?
Yep.
Okay. And there's other reasons to pick that one also. These are all natural logs, aren't they?
Mhm.
So that makes a difference there.
Next one's E.
No one's arguing, but no one's agreeing.
It's E.
Okay. I mean, hard.
I agree. I shouldn't say no one's agree. You know, it's quiet. And again, check it out, guys. The derivative, if we look at E here, the derivative of natural log of something,
1 over something.
1 over something, times the derivative of something, derivative of 2x minus 6
Next one, H.
is 2.
Last one.
What happens? This 2x minus 6 can be rewritten as 2 times x minus 3, and the 2's can cancel. Are you seeing it? Okay.
Next one's H.
Yeah.
Are you guys kind of doing a power trick here as well?
Not really.
Oh,
Okay.
I'm
So
trying to
what
work it out.
What I'm looking at, yes, I was looking at the powers.
Okay.
This one, H has x squared, and your answer has x squared. The other one has x cubed.
Yeah. So h, the derivative of natural log of something,
1 over something.
1 over something,
That's the derivative.
times the derivative of something, which is
X.
6x. Okay. Well, again, you can, right here, factor out the 3, and it's 3 times x squared minus 2, right? So 3 cancels with 6, and there's your 2x and your x squared minus 2. Process of elimination, what has to go here? F. Okay. Do you need me to show it to make you believers?
How they flip it.
Derivative of natural log of something, 1 over something, times the derivative of something, so derivative of 2x cubed, 6x squared. You'll kind of have a canceling step that'll work like h did. Where it's what? 1 over 2 times x cubed minus 3, that's 6x squared, well, 2 cancels there, and it does work. Okay. C, more matching.
Oh,
They did flip it on us, didn't they? Now, there's 4 to match with 4, but basically there's not really 4 to match with 4. There's 2 to match with 2, if you ask me.
Yeah.
Because why?
Cosine. That's not.
Yeah, you can't be putting a cosine with a cosine. Cosine has to go with sine, and sine has to go with cosine, yes? So, it's just a matter of figuring out which way it is.
First one I'm saying L.
That's
Yeah.
what I'm saying. And the next one's J.
Why wouldn't it be negative still? With the numbers?
No, because the derivative of negative cosine is positive sine.
So,
Isn't this what one?
if we take the derivative of the left, we should get the right, is what this one should be.
I just looked at the 3x plus 4.
Antiderivative.
Ah, that's really cheating, isn't it? Man, that you really don't have to do any math here if you catch those things. Okay, so cosine has to go with sine, so it's either going with L or J. And then, that's smart, I wasn't paying attention to that. 3x plus 4 has to go with
3x plus 4.
3x plus 4.
Oh, 10.
Fair enough. So that means that one's L,
MK.
and that means this one is
J.
J, because you've got to use the other sign, and 3x plus 1.
And then M and
So now sine has to go with cosine, 3x plus 4 matching, So M and then K. Okay.
Not cheating, but
Okay. We can skip the next page we've already talked about, can't we?
Should we just stop there?
yeah.
No, we only have one page left.
Yeah, but it's.
Right.
I also have like 3 minutes of class left.
Oh,
4 minutes of class.
Yeah.
It ends at 15, right?
Yeah.
Yeah. So we will stop there. We have one last page. So
It's all you need to work on. Challenge. I guess check.
now,
Check.
if you are in the mood,
No.
could you do this first page of homework?
yeah.
Really wanted to.
Yeah, you can. 1 through 14 are officially doable now. Okay, if it's something we didn't cover in the notes, go check your rules.
What about
Okay.
28?
Huh?
21 through 28 as well, right? Because it says that.
That's what I was just looking. Yeah, 21 through 28 is technically, it can be doable as well. And you're using kind of your rules and kind of a guess and check. Some of those are going to be a little tough compared to notes. I'll be honest.
Ooh,
So.
I don't like number 24.
Nice.
3t minus 2 to the 100.